Device Authority, and as you'll see through some of the slides we'll talk through, we have a security platform called Keyscaler, which is all about identity access management for IoT devices. And we have a cameo role today through my colleague Chris Torr. Do you want to stand up, Chris? You say hello? Who's one of our technology partners. And this whole discussion I want to talk through in this brief 20-minute presentation is all about chip to cloud, how we can try and make security a bit easier. It's never going to be easy, but it's trying to put those things in place to make security a bit easier from the outset. And so from this session, I'd like to at least have some understanding about what we mean by a secure by design approach for chip to cloud security, why we think an IoT IAM platform is needed for an Internet of Things type product or products, and understand how you can apply things like data privacy, token-based access control, or certificate-based access control to IoT platforms, applications, and so forth. And then the last thing is really about gaining an understanding of how and why automation for security is really important. And so we'll go over some of those challenges. But just before we start, if you think about some of the business challenges for IoT leaders, and we boiled them down here into a number of sort of key bullets. One of these, this is an important thing for me, is all about safety and confidentiality. In fact, we've seen in Device Authority a marked increase in the number of applications and use cases coming from healthcare, medical applications, where things like assistive robots, companies want to be able to remotely manage these robots inside theatres, and these things, can be dangerous if they get compromised in some way. The last thing you want is this assistive robot cutting your arm off or stealing your leg, for an example. And so being able to have a solution that manages that safety is really, really important. Personal data theft, I think Craig was talking about that previously. It's a running theme, right? You see many sort of news articles about potential breaches, personal data's been stolen, etc., etc. And that's a really important theme. Device tampering and ransomware. Again, you see many examples of that where devices have been compromised. You get a screen up saying, hey, please pay me some money. Brand damage and reputation. That's going to become even more increasingly an important factor in IoT device deployments. It's gone as the days you can stick out a device which are insecure because your brand is going to be tarnished because of potentially weaknesses in your product that you've produced into the market. Not a good thing to do. Compliance and regulatory adherence, that's GDPR is a good example of that, and that feeds into this last point here. It's about financial liability. On the upper end of the scale for GDPR is 20 million euros or 4%, whatever is the highest. You think about that for sort of businesses, that's a lot of money. And it could cause significant disruption to companies, perhaps take them out of business. So something that really has to be adhered to and understood well in your products. So moving on, I want to talk about chip to cloud today, really. And what do we mean by chip to cloud? Well, you probably can gather what's going to go on here. So we have devices on the left-hand side. So this could be anything from machines in factories, smart vehicles, medical devices, we touched on that. And there's devices in here, but that's one part of the puzzle. How do I connect my devices to my cloud infrastructure if I've got a cloud-based environment? And how do I secure that? And not to mention, how do I automate that whole process for security for all those different IoT devices? We're not talking 10 devices, typically for IoT. We're talking lots of devices, 10,000, 100,000, whatever it may be. So you can't physically touch everyone unless you've got lots of people in vans that go around and touch. Then it becomes very expensive. So then you sort of move on to, this is just a subset, right? You've got AWS, Azure hosting, the AWS IoT Core, you've got Azure IoT Hub, ThingWorks, Software AG, there's a whole bunch of IoT platforms and cloud hosting solutions out there. And if you think about AI beyond this, you think about, how do if I want to use AI on some of the data coming off these devices, the first thing I need to understand is, how can I trust the device? If I can't trust the device, I can't trust the data. If I've got random data going into my AI solution, well, what does it mean? It's really fundamental that you can trust those devices. And so the whole chip-to-cloud story is about how do I secure those devices? How can I provide a way to give that data privacy for those devices and also connect that up into my cloud infrastructure and securely and manage that ongoing security? And that's what this point here is all about, really. So how do we do that from device to cloud? So I just want to step back and look at some of the challenges there. I mean, there's a number of challenges in how you do that, right, for security from chip to cloud. But if you look at the device itself, things like trusting the device. How do I implicitly trust that device? How do I secure the device? Boot. And there's many solutions out there that can provide that. In fact, Chris will talk a little bit about Multos Secure MCU in a bit. How do I validate the app code and so forth? But there's a device side. Okay, we need to secure the device. We need to do that. What about device scale? How do I manage scale? How do I provision unique identities at scale? Back to what Craig was saying about having a single key on the device which is used to encrypt every piece of data across all your devices. Not a good idea. So you need unique keys. How do we get those unique keys on the devices? Manage those keys on an ongoing basis. Be able to rotate them perhaps. And also things like being able to authenticate the devices and not the users. We're talking about headless devices typically. How do we authenticate, trust those devices without ever touching them from remote locations? That's an interesting point. The IoT platform's obviously potentially key, or application. How do I manage device authentication into my platform? And the answer isn't just to store a static key in your device and leave it there for all the time. Or perhaps use a token which has an expiry of 20 years. Maybe not such a good idea. And also manage data privacy from my device into a back-end platform. So back to that AI story again. How do I manage that end-to-end data flow and trust that data flow to my AI solution? And the last thing here we touched on that is all about compliance. How do I adhere to those regulatory compliance requirements? So GDPR, HIPAA in the US for healthcare, and so forth. And those are some of the challenges, right? There's lots more, but in 20 minutes you can't really cover all of them. If we move on, if I can get the slide to move on. There we go. So we created this slide here. We call it the bigger picture. Actually, it's called the IET Security Solution Blueprint for Enterprise. And we recognise there's a number of steps to solve some of these fundamental problems. So you've got 1, 2, 3, and 4. So steps 1 and 2 is all about how do I manage my root keys in the manufacturing line? How do I then, as part of that root keys, how do I securely onboard those devices into my data center? And on the back-end side, on the right-hand side there, you've got things like HSMs, so hardware security modules, where lots of customers have HSMs in their enterprise. They want to reuse those enterprise HSMs secure trust points to manage certificate lifecycle management to my IoT devices. And this is where we come in, certainly from a device authority point of view. We see ourselves as the glue to all this. So I'll give you a scenario here. So I've got an IoT platform. I want to be able to manage end-to-end data encryption into the IoT platform and keep that data encrypted at rest. The first thing I want to do is securely onboard my device and register the device to Keyscaler to make sure it's an authorized device. And if that's true, then great. But I want to then manage a key to the device so that I can use that device to selectively encrypt data into the IoT platform. But that leads to the question, so okay, but how do I get a key from my key management system to be able to decrypt the data? And that's where you need to have various connectors to different IoT platforms. Unless you're bought into the whole story, hey, I've got one solution provider that can provide me everything, let's face it, not everyone does that. You need to have something like this to manage keys, to manage token-based authentication, certificate-based authentication from the devices all the way into the platform. And not all the IoT platforms and applications use the same mechanism. They're all different. This is why this IEM becomes very important. And we kind of touched on this. So this is the Keyscaler system. We have all the way from the root key and the device trust at the edge. On the right-hand side, you've got the connectors so you can plug into the likes of Thales, GML HSM, so you can automate how you deliver certificates for like AWS IoT Core, Azure IoT Hub, use Next 509. And the top bit here is really important, is operationalising that trust. So day zero, beyond day zero, okay, great, I've onboarded, but I want to be able to rotate my own credential to the device. I want to reach into my platform and push a certificate so then I can have mutual TLS conversation between the device and the platform and manage through policy how to rotate those certificates and so forth. And that's where the key value lies. So I like to use this analogy of secure by design with off-the-shelf components. And what we're trying to do here is to build out a solution where you can kind of like plug and play to make your security as easy as possible. You know, providing off the shelves for OEMs to build in security right from the outset. So adhering to that secure by design approach. And enabling customers really to focus on, you know, what they're good at. So maybe building a product which adds real end user benefit or maybe drives some business value for customers and so forth. And providing all the pieces for device and end-to-end solution is what we're trying to achieve. So all the way from the device into the cloud and how you secure that. And providing a way to give an IET IAM enabling choice for customers. I think there was a Microsoft guy once said, you know, you need at least 20 suppliers to make an IoT project successful. Well, we've certainly seen deployments where there's lots of different partners involved to make that product a success. So that certainly rings true in some of the examples I've been working with. And the last thing there is really meeting a wide range of use cases and applications. You know, if you think about medical, you think about industrial applications, maybe smart vehicle access control, all those type of things, they're all unique. They all have some similarities, but at the end of the day, they all want different things out of their solution. And you need to have something flexible to fit into that, to manage the security. So we've come up with a few options for this. We've got our Keyscaler software and our client-based software to provide a root of trust on those devices and being able to manage your security using our Keyscaler IoT IAM platform. We then have our good friends Maltos, who have built an application that runs in a secure environment on their secure MCU, which runs our code to be able to connect to Keyscaler to manage authentication, token-based auth, end-to-end crypto, certification, etc. And the last one is here about Gemalto. So we have an implementation that runs on the Gemalto modem that uses a Java implementation effectively to secure that device all the way from the product itself into the cloud infrastructure. So if we look at this in an example here, you can see where this is going. I've got my shelf and I've got a few components on there. I've got Maltos here. I've got a radio. I've got Keyscaler. I've got, actually, this is a ThingWorks platform and this is AWS. So if I fill this out, you'll see, well, okay, I've got a milling machine. Actually, it's a lathe, actually. I've got Maltos chip that runs our application to secure the sensor data coming off of this milling machine. Perhaps I want to monitor its yield, temperature, so forth. And I've got a radio technology, could be agnostic. It just depends what your radio technology is going to be. And then I've got AWS. Perhaps I want to host my solution in AWS. And then on top of that, well, I need a data aggregation or an IoT platform to manage my data. And we've got 1,000 of these lathes. And so I've got a ThingWorks platform in this example, hosted in AWS. And we've got Keyscaler hosted in AWS. But the whole point to this is to make security easy, hence the bit, of how you connect these devices to your cloud infrastructure and build out platform solutions to enable that. So that's all about, in this example, getting all the benefits of a secure MCU with an out-of-the-box application which allows you to connect to your cloud-based services, connecting all the IT components together, and it gives the flexibility to address many markets. So say I've got an application which is industrial, I can stick down an MCU, build out my cloud infrastructure, join the dots, or it could be other applications and use cases. And then this approach also supports many different security operations, whether that's secure device onboarding, perhaps I need to automate that whole secure device onboarding without touching those devices, and I want to provide an end-to-end encryption flow from my device to my back-end system, and only authorise specific users to get access to that data, or perhaps provide a way to do token-based access control from the device to the cloud infrastructure. But you get the general point there. It's all about off the shelf, and this is my shelf here. And on that note, I'm going to hand over to Chris, who's going to talk about MAOSCO's capabilities.
Well, hi there, everyone. So I'd like to reiterate first the message about not reinventing the wheel. Secure T microcontrollers, mass deployments of cryptographic devices have been with us for a long time. We all carry them around in our pockets. And we should be using the best that's out there and deploying it in this new environment. So I'll cover in a little more detail how secure micros, and of course MAOSCO in particular, can help with this chip-to-cloud message. So MAOSCO Secure Micro is based on technology that's been tried and tested over 20 years, primarily in the smart card, ID and e-passport markets. So with MAOSCO, the whole chip is protected, and everything in there. So the combination of a hardened chip and a secure operating system protects against physical and logical attacks. And actually, it's one of the few technologies, love it or hate it, to have achieved common criteria EAL7 for some of its products. So a good secure microcontroller provides a protected environment to hold your device's firmware, data and keys, and provides a safe environment for those applications to run in. And also it should uniquely identify it. Naturally, such an environment's perfect to host the device authority client, because you need to be able to trust that part of the system as much as anything else. And all the details of the messages that are passed backwards and forwards to the Keyscaler platform and all the cryptographic operations are nicely abstracted behind an API. Is it this one?
Yeah, down arrow.
Down arrow on that one. Right. So there are essentially two ways to use secure micros in an IoT device. In the simple ones, you can use it as the main microcontroller. So with MAOSCO, you can combine the functionality of the microcontroller itself, whether it's taking readings or actuating devices, with all the security functionality as well. The second way is to, if you've got something you want to use, something more powerful, or your particular chips you want to use, you can delegate the security tasks to your secure microcontroller. I mean, let's face it, IoT device manufacturers are not necessarily security experts, and you cannot really realistically expect them to be. I mean, it's a very specialised topic, and even those of us in the industry would be foolish to claim that we know everything there is to know about the subject. So if we combine these simple to deploy services and the hardware from trusted vendors, who well understand their particular subject areas, the device manufacturers can at least build in important aspects of security from the outset without having to invest heavily in expertise themselves. So this is just a diagram to try and sort of show how you can be secure from the very beginning. So during chip manufacture, it's unique to MAOSCO. I say unique, as far as I'm aware. Every chip on the wafer is injected with a unique transport key and serial number. So that transport key comes from a central key management authority. There's a global one of those, or you can host your own if you want to control all your root keys yourself. So right away, even if a wafer's stolen, it's useless to anybody. Other technologies might have a key that's very easily obtained, that's for every chip on every wafer of that product that's ever been built. That's not the case with us. And then before that chip can actually have any firmware loaded onto it, it has to be unlocked. And again, the data for that comes from the central key management authority, and it contains a unique key pair that's for that device that's certified by the KMA, and a unique owner ID. So by that stage now, the device is fully under the control of the manufacturer, and only they can control the content that goes onto it. There's a certificate-based loading mechanism, and by putting on the device authority application, you can then get the overall device registered and operational using their software. So to conclude, the whole architecture is managed from the beginning. At no one point is the device manufacturer involved in handling keys, which I think is a really important message. I think I'm out of time. Thanks.
I'll just summarise this in the last slide. Is really, so just to summarise, you know, really think you should use off the shelf solutions to build out your security into your products. Pull in the experts and solutions to complement your product. You don't have to be experts in everything. And use solutions which enable you to operationalise security at IoT scale. Right, that's one of the fundamental things. There's a whole bunch of stuff in there, right? But I'll just pick out a few things. Adopt a methodology in your businesses. I think that's a key thing. It's not just about the product and security. It's about a methodology and a way to work in the business. And the last thing really there is about building a culture to make sure you've got that culture to make sure you build the security into your products. That's really it from us too. I know, appreciate we're a minute or two over. But yeah, thank you very much. And if you've got any questions, please fire away.
No, please don't.